Welcome. In this short video lecture, we are going to discuss about finding inverse Laplace transform of a function. My name is Vincent. I teach mathematics at School of Engineering, University of Nairobi. So here's the problem. Determine the inverse Laplace transform of the function s squared plus 1 over s plus 2 squared into s squared minus 5s plus 6. So the key thing here, the first thing is to decompose this function in partial fractions. And then after decomposing it into partial fractions, you will be able now to get the value of the inverse Laplace transform easily. So one thing that you have to note first is that the function, the expression 5s s squared minus 5s plus 6 is a quadratic expression. Product is positive 6, sum is minus 5. So which tells you that the numbers are minus 2 and minus 3. So this can be written as s squared minus 2s minus 3s and then plus 6. And then when you do the pairing, so s into s minus 2 minus 3 into s minus 2, so that we have s minus 3, s minus 2. So therefore now we have s minus 3, s minus 2 as the factorization of this expression, so that the function we have, f of s, is s squared f of s is given by s squared plus 1 over s plus 2 squared, and then into s minus 3, s minus 2. So the partial decomposition of this function will be of the form a over s plus 2 plus b over s plus 2 squared, and then plus c s minus 2, and then plus d s minus 3. So that is the correct form of the partial fractions of a function of this form. So we'll have s squared plus 1 over s plus 2 squared into s minus 2, s minus 3 will be given by, so LCM remains to be the same denominator, s squared into s minus 2, s minus 3, and then please divide this one, a into s plus 2, s minus 2, s minus 3. This one will be b into s minus 2, s minus 3, and then this will be s plus 2 squared, s minus 3, and then plus d into s plus 2 squared into s minus 2. So this is what we have. And therefore, s squared plus 1 will be equivalent to this numerator, a into s plus 2, s minus 2, s minus 3, plus b into s minus 2, s minus 3, plus c into s plus 2 squared into s minus 3, plus d into s plus 2 squared into s minus 2. So if we set s to be minus 2, then this term will go to 0. This term will also go to 0. This term will also go to 0. So left hand side will have minus 2 squared plus 1 equals to b minus 2 minus 2 minus 2 minus 3, which tells us that this will be 4 plus 1 equals to, so minus 4 minus this minus 2 positive 24b, which tells you that 5 equals to 24b. So telling you that b is the same as, so this is minus 2 minus 2, this minus 4 minus 5, this 20, not 20, so this 20, so this is 20. So b will be 5 over 20, which will give you 1 over 4. So that is what we have as our b. And then when we set s to be 2, then we'll have 2 squared plus 1 equals to, so 2, this will be 0, this will be 0, this will be 0, so we'll remain in this part alone. So we'll have c into 2 plus 2 squared, and then multiplied by 2 minus 3. So this will be minus 1. So minus 1. Then times 2 plus 2, which is 4. 4 squared is 16. 16 times, so minus 16. So telling you that 2 squared is 4 plus 1, 5. So 5 equals to minus 16c. So c is minus 5 over 16. And then setting s to be 3, then this term will be 0, this term will be 0, this term will be 0. So remain this part. So we'll have 3 squared plus 1 equals to d into 3 plus 2 squared into 3 minus 2. And when you work out this one, you get d. So this 3 plus 2 is 5. 5 squared is 25. So 25d. This would be 10 equals to 25d, which tells you that d equals to 10 over 25, and 5 to 5, 5. So get 2 over 5. So then the remaining bit is just to get a. But a is very easy to get because if we relate coefficients here, so relating coefficients, if you have to, we can actually say this is 0 s power 3. So this term will have a s power 3. At this point, you don't have an s power 3. This point here will have plus c s power 3, because there are 2 s squared will be here, then this one here. Here we'll have plus d s squared, and this one s power 3. So it tells us that a plus c plus d s power 3 is what we'll have on the right hand side. and left hand side is 0 s power 3. So a plus c plus d is 0, but we know which tells us that a is minus c minus d, which will be minus. So minus c will be, so minus 5 over 16 plus 5 over 16 minus d 2 over 5. LCM is 80. 80, so 5 by this 25. 16, this is 32. So 25 minus 32 is minus 7 over 180. So we'll get, so this is d, which is 2 over 5. So then minus c 5. So this is 25, and then 16 times 2, 32. So this is minus 7 over 80. So therefore a equals to minus 7 over 80. Thus, we have capital F of S will be given by 1 of minus 7 over 80 multiplied by 1 over S plus 2, and then B is plus 1 over 4, and then 1 over S plus 2 squared, and then minus C is 5 over 16, and then 1 over S minus 2, and then plus 2 over 5, and then 1 over S minus 3. So this now you get now the inverse Laplace transform of this function. So it should be the inverse Laplace transform of this one. Actually, I can factor out minus 7 over 80, 1 over S plus 2, plus 1 over 4, inverse Laplace transform of 1 over S plus 2 squared, and then minus 5 over 16, inverse Laplace transform of 1 over S minus 2, plus 2 over 5, inverse Laplace transform of this term here. So inverse Laplace transform of this one will be now a function in terms of t, which will be 1 minus 7 over 80. Here is a standard one, whose value is e raised power minus 2t plus 1 over 4. And then this is actually standard one for t, e raised power minus 2t, and then minus 5 over 16, and then e raised power 2t, it's also a standard function, and then plus 2 over 5, e raised power minus plus 3t. So this what we get here. So therefore, this was the correct answer to the given problem. So thank you.